Hello and welcome. We're glad you have joined us. My name is Amit. I'm a Microsoft technical trainer specializing in security and AI. I am here to walk you through the AZ-305 course, Design Infrastructure Solutions. In this session, we will cover how to design authentication and authorization solutions Part 2. We will focus on governance for identity and access to make sure that access is intentional, that applications authenticate securely, and that secrets are protected at scale. We will explore design considerations for access reviews, service principles for applications, and for Azure Key Vault. So let's get started with this session. How do we continuously validate that the current access still makes sense? We can design for access reviews. If an auditor asked you today, who still needs access? Could you answer this with confidence? Manually evaluating access can be time-consuming. Access review helps simplify and streamline the process. They are great for lifecycle management. They help us keep on track who currently have access and should they still have it. We can approve or revoke access when it is no longer needed. With human reviewer or with an automated format. We can easily automate onboarding and offboarding with access reviews. When a new employee joined the company, they need initial access to corporate resources for applications. When they change roles, for each position they hold, they need different access and privileges. And when they leave the company, their access should be revoked. What kind of access can we review? We can review group memberships, application access packages, and role assignments with a self-review with one or multiple reviewers. As always, start small with a pilot and communicate clearly. We highly recommend to perform periodic review of admin roles, guest access cleanup, and sensitive app access. I always keep my global admin and owner role under strict review cycle. Now, we move from human identities to non-human identities, apps and workloads. Our app needs an identity too. Otherwise, it becomes password in config files, which is a recipe for trouble. Let's see how to solve that by designing service principles for applications. Picture this. You're building an app in Azure, and all it needs to do is read a secret from a key vault and write some data to an Azure Blob storage. In the old days, that usually meant juggling passwords, storing secrets and connection strings, some were safe-ish, and remembering to rotate them before they expired. Managed identities change that story completely. When our app is hosted on an Azure resource, we can enable for it a managed identity. It is basically giving it a built-in identity in Entra ID, allowing us to provide granular permissions to other resources through role-based access control. Now, when our app needs to access something, just ask for Entra ID for a token. Azure checks what permission the identity has through the role-based access control, and access is either granted or denied. No usernames, no passwords, no certificates in your code, no rotation required. That leads to fewer security risks, far less operational overhead with full monitoring capabilities, and it's completely free of charge. There are two types of managed identities: system-assigned with a 1-to-1 ratio and user-assigned with a 1-to-many option. System-assigned managed identities is useful when we need accurate trackability. Which resource used its permissions? It shares the resource lifecycle. That means that if you remove the resource, the identity will be deleted as well. It allows us full granularity and visibility on what resource is granted with which permissions. If your workloads are recycled often, User-assigned managed identities keeps permissions stable while the instance change. It is also very common to use when deploying through infrastructure as a code tools to streamline permission management ahead of the deployment. A deployment uses multiple virtual machines that are frequently rebuilt by auto-scaling but all need the same access to an Azure storage account. For that, you can create one user-assigned managed identity granted with permissions and attach it into multiple VMs, even when they are recreated. Let's say that we have a virtual machine that it needs to access a Key Vault since its admin credentials are stored there as a secret. How do we do that? The answer is clear. Use managed identities. We will enable a managed identity for the virtual machine granted with granular permissions to only consume the admin credential secret. Role-based access control assigned on the secret level Key Vault secret user. Now I can connect to the VM without exposing any credentials. Managed identities are great when the app is built on Azure. But what about external or non-Azure hosted applications? That's when we consider service principals. A service principal is the identity an application uses inside a specific Microsoft Entra tenant. Think of the original app registration as the blueprint and the service principal as the real working copy created in each tenant that uses the app. When an external or a multi-tenant application is being used, for example, an app built by tenant A and used by tenant B, Microsoft Entra create a service principal in tenant B and assigned it with only the permission that the tenant approved. The application then authenticates using a secret or a certificate and can securely access Azure resources. What do we get from it? Control and isolation. Each tenant manages its own permissions, can review or revoke access at any time, and doesn't affect the application global definition. This is making service principals your go-to solution for external, non-Azure hosted, or cross-tenant applications. Let us examine the relationship between the application object and the correlating service principals. Datium is a company that developed a multi-tenant application called HR App. The process of creating the application and service principals object is in the home tenant, with appropriate access to resources. When the consumers of the Azure app, Kentasso, and Fabricam complete permission consent, a correlating service principal object is created in their Entra ID tenant, representing an instance of the application at runtime, which is assigned with the permission that administrator provided. When building applications that use Entra ID, a few smart permission habits make a big security difference. Start by deciding whether the permission really need admin consent or if user consent is sufficient. This should always reflect your business and security requirements. We should only ask for permissions that the application actually uses. If your app does not generate notifications, why allowing it to read app-generated notifications? Always aim for least privileges, because every extra permission increases risk. If your app asks for read all mailboxes to show a profile picture, that's a red flag. Apps should also handle consent denied gracefully. No crashes, no broken user experience. And we get a great governance control. We can restrict user consent to verified publishers and to selected permissions. Allow us to centralize risky decisions with identity or security admins. For multi-tenant applications, tenant A owns the application. Tenant B is initiating the application via service principal. A user from tenant B attempts to sign in to the application. The authorization endpoint requests a token for the application. The user credentials are required and verified for authentication. Then, the user is prompted to provide consent for the app to gain access to tenant B resources. The Microsoft Identity Platform uses the application object in tenant A as a blueprint for creating service principal in tenant B. Then, the user receives the requested token. Now, for a secure storage solution for encryption keys, secrets, and certificates, Azure Key Vault. Instead of hard-coding secrets into your apps or scattering them across configuration files, Azure Key Vault centralizes them in a protected service where access is explicitly granted and fully audited. Our application don't know secrets anymore. They authenticate using managed identities or service principals. They request exactly what they need when they need it. That's zero trust. Assume breach, verify explicitly, and use less privileges. Think of a web application pulling an API key at runtime, or a virtual machine retrieving its admin password without any human ever seeing it. This separation is critical. Developers focus on code. Security teams control access and monitoring, and sensitive data stay out of source control, configuration files, and deployment templates. Beyond secrets, Azure Key Vault also plays a critical role in cryptography and compliance. From an architectural perspective, it supports our design need for secure, compliant, and scalable data solutions that addresses vulnerabilities of data at rest and data at transit. When regulation requires control over encryption, we can use our own customer-managed keys, software-protected or hardware security model protected, to encrypt data at rest in services like storage, SQL, or Cosmos DB, meeting compliance standards like FIPS 140. And for data in transit, Azure Key Vault simplifies enrollment, management, and deployment of public and private TLS and SSL certificates, allowing our application to renew certificates automatically without ever touching private keys directly. Secrets, keys, and certificates becomes governed, auditable design decisions. When we are designing with Azure Key Vault, start by asking the right architectural questions. Do we need one or more vaults? This is our security boundary. A single shared vault is simpler for centralized management by a regional deployment, for example. But separated vaults reduce the blast radius of a security event. Separating key vaults by an application is the most common boundary. How do we secure access to the Key Vault? Authentication over secure transfer is the default. For authorization, we can use either access policies, which can be very useful for tightly scoped legacy scenarios, or the recommended one, leverage role-based access control, newer option that allows us better governance and scale. Ask, should this Key Vault be public or private? As a platform solution, Azure Key Vault comes with a public endpoint that can be protected by built-in firewall and networking rules. In real environments, we usually restrict vaults to private endpoints, so secrets, keys, and certificates are never reachable from the public internet. What about data protection? All Azure vaults are protected by soft delete mode. This is designed to prevent accidental deletion of your vaults, keys, secrets, and certificates. Think of a soft delete like a recycle bin. It allows you to quickly recover and return back to work. We can even enhance that protection to prevent the deletion by a malicious insider with purge protection, so even with high privileges, the data is kept for the entire soft delete period. Let's review with a use case. Let's examine the requirements for the Tailwind Trends organization. The development team has an application running on an Azure virtual machine, and data is stored in an Azure SQL database. they need to find a way to securely allow the virtual machine to query the Azure SQL database. They also need an on-premises server to be able to securely access the SQL database without storing credentials in the application code or configuration files. Let's see a sample solution that might be a good fit for that scenario. Remember, multiple solutions might be a good fit depending on your requirements. First of all, we will create the Azure boundary and the on-premises boundary. After that, we start with the network. We segmentize it by subnets, add protection from network security group. This is where the VM will be located. Now, let's build another subnet and protect it. This time, I would like to provide private access for my SQL database, so we will create a private endpoint associated into my SQL database. No public access is allowed. For the virtual machine to access the database, we can create a managed identity. Grant it with role-based access control using list privileges directly to the SQL DB. Now, for on-premises, we have a network with an app server on top of it. We'll connect securely via VPN device. In Azure, we need to configure the virtual network gateway on its own reserved name subnet, the gateway subnet. We'll create a site-to-site connection. Encrypt the tunnel over public IPs. To allow the external app server to access to the SQL database, we will use Entra ID. We will register the application to Entra, which will create the correlating service principal or enterprise application. Now, we can use role-based access control for secure, granular access to our database. In this session, we have designed for access reviews, service principals for applications, and for Azure Key Vaults. This concludes our Design Authentication and Authorization solution module. There are many ways to continue your learning journey. We encourage you to watch other videos in this course or search out your next favorite topic on Microsoft Learn at aka.ms/learn. I'm Amit Nair. Happy learning!